इस क्वेश्चन में दिया गया कि कोई मेटालिक ब्लॉक है कैरिंग करंट आई करंट कैरी कर रहा है सब्जेक्ट टू यूनिफॉर्म मैग्नेटिक इंडक्शन बी एज सोन इन फिगर। कोई मेटेलिक ब्लॉक है जिसको क्या कर दिया गया है, मैग्नेटिक फील्ड में रख दिया गया है। मैग्नेटिक फील्ड अपवर्ड डायरेक्शन में है और एक्स कैप डायरेक्शन में क्या हो रही है, उसमें करंट फ्लो कर रही है। ठीक है, ये करंट का डायरेक्शन हमें दिखा रखा है उसने फिगर में। द मूविंग चार्ज एक्सपीरियंस फोर्स एफ। ये जो मूविंग चार्ज है ये क्या कर रहे हैं, फोर्स एक्सपीरियंस कर रहे हैं, कितना, एफ। ओके, गिवन बाई विच इज, गिवन बाई तो इसकी वैल्यू क्या होगी, विच रिजल्ट इन लोअरिंग द पोटेंशियल ऑफ द फेस। तो किधर की फेस की पोटेंशियल क्या हो जाएगी, लेस हो जाएगी। यही हमें क्या करना है, बताना है। तो अगर यहाँ करंट फ्लो कर रही है तो मूव कौन कर रहा है, इलेक्ट्रॉन्स मूव कर रहे हैं। ठीक है, और जब इलेक्ट्रॉन्स मूव कर रहे हैं वो मूविंग किसी मैग्नेटिक फील्ड में है तो फोर्स क्या होता है, क्यू वी क्रॉस बी होता है। ओके, तो हमारे यहाँ पे मतलब क्यू की वैल्यू क्या है, माइनस ई के इक्वल है। और वेलोसिटी किस डायरेक्शन में है, वी एक्स, या वी, या वी जो है हमारा क्या है, माइनस वी एक्स है। ओके, आई कैप डायरेक्शन में है। तो वेलोसिटी क्या है, वी है, उसने बोल रखा है कि वी लेना है तो हम वी ही ले लेते हैं, काहे के लिए वी एक्स लें। तो वी माइनस वी आई कैप हो गया। ठीक है, ये वेलोसिटी हो गई उनकी। तो जो फोर्स आएगा वो क्या आएगा, तो फोर्स आ जाएगा माइनस ई वी आई कैप माइनस में, और ये क्या आएगा, क्रॉस बी। बी किस डायरेक्शन में, वाई कैप डायरेक्शन में है। तो बी, ये जे कैप हो जाएगा। ओके, ये कितना आ जाएगा, जे कैप, ये आ गया। तो एफ इक्वल्स टू क्या आ जाएगा, ई वी बी आई क्रॉस जे क्या होता है, के कैप होता है, और माइनस माइनस क्या हो जाएगा, प्लस हो जाएगा। तो जो फोर्स लगेगा इलेक्ट्रॉन्स पे वो कितना लगेगा, ये लगेगा ई वी बी क्रॉस के कैप। अब उसने बोला है कि कौन से फेस का पोटेंशियल डिक्रीज करेगा। तो फोर्स का जो फेस है, जो इलेक्ट्रॉन्स हैं किस डायरेक्शन में मूव करने लगेंगे, के डायरेक्शन में, के कैप डायरेक्शन में मूव करेंगे। तो करंट क्या होगी, इस डायरेक्शन में मूव करेगी। तो यहाँ पे जो फेस होगी वो फेस होगा कौन सा, ए बी सी डी। ओके, तो आप फोर्स की वजह से देख सकते हैं कि फोर्स की वजह से जो इलेक्ट्रॉन्स हैं ये किस डायरेक्शन में मूव कर रहे हैं, जेड डायरेक्शन में मूव कर रहे हैं। तो सारे इलेक्ट्रॉन जिस डायरेक्शन में मूव करेंगे तो वहाँ पे क्या होगा, पोटेंशियल डिक्रीज होगा। तो इस वजह से जो फेस होगी वो क्या होगी, ए बी सी डी फेस होगी। ओके, तो ये हमारी फोर्स की वैल्यू और ये फेस हो गया, यही हमारा रिक्वायर्ड आंसर है।
Hello students, let's understand again question. A rectangular loop PQR is made from a uniform wire has a length of A, width B, mass M. It is free to rotate about the arm PQ which remains hinged along the horizontal line taken as y-axis. See the figure. Take the vertically upward direction as z-axis. A uniform magnetic field vector B is equal to 3 I cap plus 4 k cap B naught exists in the region. The loop is held in the xy plane and current I is passed through it. The loop is now released and is found to stay in the horizontal position in equilibrium. So question is saying that we are having a rectangular loop PQRS and suppose current I is flowing like this in a clockwise direction, that this magnitude is I, okay, and one of the magnetic field vector B is in K cap and I cap direction, okay. So we have given that this wire is uh, released from the rest and this is found that this is in equilibrium. So this wire, this loop will be in equilibrium when the net torque applied on this loop is equal to 0. So torque net is should be equal to 0. Okay, that means total torque applied on this loop is equal to 0. Now we know that due to mass m of this loop, gravitation attraction force is always applied at the center of this loop. So we can calculate the torque applied by the mg force. This is equal to vector r cross vector f. Vector f we know that in this is in negative direction of z, so minus of mg k cap. And perpendicular direction to this is minus of a by 2 and this direction is I cap. Okay. So vector r we have to take minus of a by 2 I cap cross mg minus of k cap. Okay, so torque applied by the mg force will be equal to minus to minus plus mg a by 2 I cross k is always equal to minus of j cap. So torque applied by the mg force is in negative direction, and this will be, suppose this is in like this direction. Okay. Now we know that due to the current flowing in this direction, a magnetic field here in this direction, there is a force applied on this wire. Okay. Now we can see that only the current directions are different in QR and PS wires. QR arm having current direction like this, and SR having current direction opposite to this value. Okay. So we can say force applied on this wire due to this magnetic field be, suppose we can say in any of the direction, any particular direction. So force applied on this direction will be opposite to this wire. Okay. So they will cancel to each other. So net force due to this QS, SP and RS is equal to 0. So F net due to PS and RQ arm is equal to 0. So there is no torque, no net torque. Net torque due to PS and RQ is equal to 0 because net force on these are equal to 0. Okay. Now this PQ arm is hinged. This is given in the question. So torque can be possible to balance this torque due to mg force. This is only due to RS. So we have to write for the RS arm. For RS arm, first of all we have to calculate the force applied on this wire due to magnetic field. So we know that force on RS, vector RS is equal to current I into vector L cross vector B. Okay, so we have to tell the values here. Vector RS, vector FRS is equal to I into vector L. We have given minus of B j cap because this direction is y direction cross. Now this is given 3 I cap plus 4 k cap, 3 I cap plus 4 k cap B naught. Okay, now we can simplify this. So vector of RS is equal to I we can take common. Sorry, here 3 I cap plus 4 k cap, right? 3 I cap plus 4 k cap. Okay, so we can take I into B naught common. So what we have, minus of B j cap cross 3 I cap plus minus of B j cap cross 4 k cap. Okay, now again we have to simplify this. So vector of RS is equal to I B naught is equal to, this will be J cross I is equal to minus of k cap. So 3B, minus to minus cancel out. So this will be k cap only. We know that I into I cross k is equal to k cap. So J cross I is equal to minus of k cap. Minus of minus, this will be plus. Plus here we have minus of j to j cross k. J cross k is always equal to I, and we have given minus, so minus of 4b. Okay, so we got this value. So vector 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 FRS is equal to I B naught 3b k cap minus 4b I cap we got. Okay, now we have to calculate the torque applied on this RS arm due to this force. So we know that torque is always equal to vector RS cross vector F. Now vector R is for this arm is equal to this distance we have given from the hinged point. About this it can rotate. So this is minus of A by 2 I cap. So minus of A by 2 I cap cross I B naught, we can take common, 3b k cap minus 4b I cap. Okay, now again we can simplify. So we can take I B naught A by 2 common, and here will be minus of I cap cross 3b k cap plus minus of I cap cross minus of 4b, it is I cap. Okay. Now I cap to I cap, this will be 0, and here we have I cap cross j, I cap cross k cap. So k cross I is equal to j, so this will be minus of j, minus minus plus. So plus j cap we got 3b, and here we have I b naught a by 2. So this we got torque on this arm Rs. Okay. So we can say that, and we can say from the equation first, torque applied by the mg force on this uh, PQRS loop is equal to, in the minus of j cap direction, means in this direction. Okay. And torque applied by the force in RS arm, this is in the positive j cap direction. So from these equations we can see torque applied in the opposite direction. Okay, means they are balancing, so magnitude should be equal. Okay, so vector rs, this is equation second, mode of vector rs should be equal to mode of vector mg, sorry, mode of vector tau rs, mode of vector tau mg. So we can write here mg into a by 2 is equal to I b naught into a by 2 into 3b. Okay, so here we can write here, sorry, distance we have for the this value, this perpendicular distance of minus of a cap, minus of I cap, a I cap. So this is minus of I a cap, minus of I a cap. So we have to make it a in place of a by 2. So this we got. Now what we have to calculate, we have to tell according to a question what is the direction of current in PQ. So torque applied by this mg force in the j cap minus of j cap direction, and torque applied uh, on, on the SR arm is in the positive y direction. So we can say they are balancing, that's why there is no torque applied, and that's why this loop is not rotating. So we can write here the current direction, but whatever we have taken, this is correct. And we have seen that current direction we have taken is in this direction. So we can write here that current direction is current direction is current direction is plus y-axis. This is answer of the A question. Now we have to tell the answer of the B question. Find the magnetic force on arm RS. Arm RS, we have already calculated magnetic force vector FRS is equal to I B naught 3B K cap minus of 4B I cap. Okay, so we can write here that B's answer is force on RS is equal to I B naught 3B K cap minus 4B I cap. Okay, now third question is find the expression for I in terms of B naught A B M. So we can calculate from this value. This is equation third. We can write here from equation third. From equation third, we have I is equal to A cancel out. So what is remaining? Mg by B naught, Mg by 2 by P naught into 3B. This is equal to value of I. So this will be equal to mg upon 6 B naught into B. So current I value we got here. I is equal to, this is mg force and this is total current I we are getting. and I is equal to mg upon 6 b naught b we got. So this is the answer for this question. I hope you understood the solution. Thank you.